Here we're going to name and draw some alcohol. So very first one is pretty much the simplest and most commonly known alcohol we can deal with, which is ethanol. Ethanol has eth as a core of its name, so that means we're dealing with something which is two carbons. We know that it's AN, which means it's alkane, which means we're dealing with single bonds. And then we know it's an alcohol, but it doesn't specify the number. And the reason it doesn't specify the number is that because there's only two carbons, there's only one way that you could actually draw this. You would have two carbons, and then bonded to one of the carbons, you'd have an OH group, a hydroxyl group. All of the other unbonded spots on the carbons become hydrogens, and that's our ethanol right there. Now, a common way that we'll write this actually is we won't show a bond between the oxygen and hydrogen. We'll just write the oxygen and hydrogen right next to each other. So the OH group is almost written as if it's a single atom, even though it's not. And it doesn't matter which of the hydrogens you replace with the OH group either. You could just as easily move it over here. And this is 100% just as valid as putting it where I initially put it. We could also simplify this molecule down to a line drawing. There's our two carbons. It's just a single straight line because we have two vertices on the end. And then we'd make one more line with the OH group coming off of it. Very, very simple. Both of these are valid ways of writing it, but because ethanol is so simple, we would probably use this uncondensed formula, or we'd write it as a condensed formula like this. It's pretty easy to show all of the carbons on there. One other thing that we often do, if we have the OH group, say, attached to the other side, the bond is actually to the oxygen. So we will actually draw the oxygen flipped around the other way. So that is an HO group instead, so that we can show the bond going to the oxygen instead of showing it going to the hydrogen, which of course is bonded to the oxygen itself. It's a little detail. It's not going to trip you up on diploma or anything, but it is worth pointing out that this is really the exact same thing. It's just a convention to show the proper bonding. If we take a look at a bit more complicated of an alcohol, this is cyclobutane 1223 tetraol. So we got a couple different things going here. This is cyclic because it's cyclo. We have 4 carbons. And then we have 4 hydroxyl groups on those locations. So the way I'm going to draw this is I am going to start off with drawing my core. This one, I'm just going to do a line diagram. I am not going to bother trying to make this with a condensed diagram because it's going to get pretty messy pretty quickly. So we have one OH group on carbon 1. Doesn't matter which one we pick. So I'm going to start there. We have 2 OH groups on carbon 2. And then we have a third on carbon 3. And you'll see I reversed that last hydroxyl group, just like I was talking about above. So it works pretty much the exact same way as we always do it. We start with that core on the inside, which is our 4 carbon ring. that goes along with the cyclobutane. And then we just add in all of the substituents. Here we have a drawing that we need to name. There's potentially a lot of different ways, because we have branches involved with this, that you could number this off. You could go 1, 2, 3, 4, 5. You could go 1, 2, 3, 4, 5, 6. You could go 1, 2, 3, 4, 5, 6. So which one do we end up using? Well, the one we're going to want to use for this one is we're going to want to use the blue. And the reason that we're going to want to use the blue is that the purple I can just get rid of because it's not the longest one. It's a 5-carbon parent chain instead of the longer 6-carbon parent chain. Between the blue and the brown, in chemistry 30, we would definitely prefer the blue because we do not want to have branches on branches. If we use the brown numbering scheme, we do actually get a branch on a branch. At higher levels of organic chemistry, you could actually name that double branch. But we're not going to do that in chemistry 30, so we're going to prefer to use that blue numbering scheme. Which way would I want to number this? Would I want to start this with carbon 1 here, or would I want to start it with carbon 1 here? Of course, we'll number it this way or this way. Well, I would want to start with that bottom carbon. And the reason I want to start with the bottom carbon is because I want to get my hydroxyl group with the lowest number. You'll actually get lower numbers on the branches if you use the top carbon, but the branches are less important than the hydroxyl group. So we're going to number it off in a way that prefers giving the hydroxyl group the lowest number possible. So we would have 1, 2, 3, 4, 5, 6. So then that gives me the start of my name. I know that the start of it is hex. I also know that these are all single bonds. So that would put an AN after it. The hydroxyl group is on carbon 3, so I can end it off with 3 all. Then I just have to worry about the stuff in front. I have both a methyl group and an ethyl group. The ethyl group is going to have to go first, so I'm going to start it with 4 ethyl and then 5 methyl, because they're on carbons 4 and 5 respectively. And then all I need to do is stick everything together. I can cheat because I'm using a computer and literally just move them. So this would give us a total name of 4 ethyl, 5 methyl, hexane, 3 all.